Hello, everyone. So I am a night owl, so if any of you are too, then thank you for being here. I'm going to talk today about using microcontrollers for education. It's something I've been doing for about 7 years now, and it's a subject that I've learned a lot about. So if any of you are educators, if any of you are beginners, or if any of you are looking to do your own classes, hopefully you will learn a little bit from some of my mistakes and some of the accomplishments I've made over the last several years. So what can we unlock with microcontrollers in education? What are the things that we're actually trying to do? Well, one is definitely cost. You can get away with giving everyone a pretty great kit on a budget and make sure that they have a lot of capability, and you can do it for a very small budget with microcontrollers. When it comes to ethical hacking lessons, you can teach a lot of the same lessons you would need something like a Raspberry Pi or a full computer to teach. And when I first started getting into ethical hacking, I did not have much money. So the budget was a very critical thing for me, and this ended up being a great thing to specialize in because it meant I could put together some pretty great classes with a very small budget. So we can teach soldering lessons, of course, but also Wi-Fi and networking classes, which were really my focus in the beginning. We can teach rapid prototyping. We can teach Python on hardware, which is something relatively new. And we can also learn about grant funding, because a lot of these things are actually different subjects that there is a lot of money out there for. So I was able to do a lot of my classes via grant funding, and that was one of the big transitions I had over the last several years, was going from having the attendees paying for the classes to instead having the state, the government, and other entities pay for those classes and keeping it free for students, which was fantastic. So we're going to go through some case studies. We're going to talk about working with null space labs, of which hopefully many of you are familiar, and working with them to do some classes in their space. We're going to talk about the Mozilla Makerspace classes we've been working on, which are grant funded as a case study. And then also our Cyber Montana CyberCat Academy, which was one of my favorite classes we've done. That was a week-long cyber camp we actually did for middle school to high school age kids. That was mostly middle school, and that was by far the most challenging one that we've taken on. And that one was also entirely grant funded. So last year, because we've actually added a couple since I did this presentation before, we did 12 workshops in Los Angeles. We did 7 workshops at the C3 conference in Germany. We did 7 workshops in Montana, 1 week-long cyber camp, and 75 hours total of instruction time, which was a good deal. So that's in-person like workshops. We also do a lot of online stuff, but I'm kind of keeping a lot of this to in-person workshops today. So who am I? My name is Kody Kinzie. I'm an ethical hacker. I work at a company called Varonis, but I also have my own side project with my friends that's been going on for years, and you might have seen some of my content on channels like Nullbyte, Hack5, Redia, Security Forward. I did an interview with David Bumball, some other cool cyber people. So I'm all over the place. My specialty is in creating ethical hacking like education. So trying to get people who are complete beginners or maybe switching in their careers or haven't tried something before to feel comfortable enough to try something new and stick with it. That's really hard. So it's kind of weird that that's what I specialize in, but I really enjoy getting people to understand things for the first time, and I love these kind of top-level subjects to get people enthusiastic about learning maybe electrical engineering, maybe ethical hacking. But doing these sorts of workshops and getting out there has been my way of connecting with people who love the same kinds of things. So that's why I'm so passionate about it. I created the Nullbyte YouTube channel. A lot of people think I still own that, but the company who I was working for at the time actually does own it and then went out of business. So if you haven't seen any updates on that YouTube channel, some exciting news. The new owners reached out to us, and we might actually be making some new Nullbyte videos pretty soon. So if you're a Nullbyte fan, don't lose hope. But if you've never heard of me before, I also like to make prototypes, and some of the ones that I'm going to be talking about today, I've been using for teaching ethical hacking for the last several years. So, yep, I already mentioned Nullbyte and Hack5. Those are the 2 channels where most people know me from, but because I do a lot of ethical hacking education, naturally making those sorts of videos are very easy for me, since this is what I would be doing for free all the time if no one paid me. So it's a great way of getting to hang out with my friends and make cool stuff. And if you want to meet more of us, we're over at the Redia table in the ethical hacking, in the hardware hacking area. We have the ethical hacker shirts on, and it's hard to miss us. All right, so my first forte into hacking was with the Raspberry Pi. It was the most affordable computer at the time. If I smoked it, then no big problem. Like, I could get a new one for about $35. That has all kind of changed. Raspberry Pis have gotten more expensive, and there are lower cost alternatives now that I would say are just as beginner friendly. So when I first started getting into ethical hacking, I think it was like 2016, 2017, something like that. This was the best choice, at least in my opinion. Raspberry Pi, I taught a lot of videos about Raspberry Pis, and I think this one has 1.7 million views on YouTube. So there was a lot of, let's just say there was a lot of interest in Raspberry Pis at the time. But while those are really good for teaching Linux, networking, I found that as time went on, they got more expensive, and then subsequent versions of the Raspberry Pi didn't support critical features that I really wanted to teach about. Like some of the newer Raspberry Pis don't have the unlocked Wi-Fi radios that let us do some of the Wi-Fi hacking stuff that I love to teach. So it became a bit of a fragmentary experience, it became more expensive, and we wanted to instead move on to something that was even cheaper. So I went to Pasadena City College. I don't know if you know this, and I don't think they advertise it as much as they should, but this is actually the school where Worf from Star Trek went. I think they should have a statue of him out front, and in lieu of that, I've made my own. But while going to the School of Worf, as we call it, I studied electrical engineering. And originally I went for computer science, but I found that that department was in a little bit of disarray. When I went around and I found people who were really passionate about what they were teaching, the electrical engineering people were just like amazing. And if any of you know Professor Thoen, Thomas Thoen was my first electrical engineering professor, and he sold me on the whole thing. So he's the reason I got into microcontrollers, as well as my friend Huron, who I think is around the conference somewhere. The two of them recommended I get into microcontrollers, I try it out, and it really appealed to me. So I started getting more and more into microcontrollers. I started also working with other students at PCC to start doing workshops based on those microcontrollers and CTFs, and that's how I got started teaching with microcontrollers. So originally we did one of our very first CTFs, my friend Brandon and I, who's in the other room running a different workshop, we did a CTF at LayerOne called, oh my gosh, the Chicken Man game. That was our first super crazy CTF. It was discouraging for beginners, it was hard on the instructors, it was a mess. A lot of people had a good time, but not us, because it was very, very difficult to set up, and it really made me think that this might be too hard for beginners initially. So my first feedback with microcontrollers, trying to do it at like a conference, kind of scary. But we decided to address some of these challenges and kind of calling them out. These are the things you can expect to be a little bit tricky if you're teaching with microcontrollers. First, every operating system has a different software, serial programming, flashing interface, and learning how to do simple things across 3 different operating systems is going to get really tiring on your instructors. So if you have people showing up and they're like, yes, I run Fedora. Oh, I run Cubes OS. I'm like, well, that's great for you, but now my instructors have to find a completely new set of bugs, fix them, often on an operating system they've never worked on before. It really makes it quite difficult to find helpers for these classes. It kills the momentum when students have random errors and can't follow along. If we lose about 15 to 20% of the class, it's over in terms of momentum. It's really hard. And no one solution works for everything. It's all operating system specific. It's really rough. So more assumptions means having a worse time. So if we're assuming that all of these people are going to have like the same operating system, they're not going to run into bugs, they're going to be able to flash it, they're going to be able to communicate it with it, it really makes a ton of assumptions that every single class is riding on. And if those assumptions don't come true, we're in a lot of trouble. So this was our Chicken Man game. We had some excellent guests who also came and instructed this group, one of which is in the crowd today. And this was our adventure at PCC, where we had people connected to this microcontroller, and basically what it was doing was generating Wi-Fi handshakes, because the people who were in charge of the space were like, you absolutely cannot do deauthentication. So we created this little Wi-Fi hacking game. It ended up being pretty fun. And yeah, the complicated setups, the compiled languages, the classroom hardware struggles with getting everything set up, and also we were learning about people's BIOS settings, something I never needed or wanted to know about. These were things that made those classes incredibly difficult at first. So here are the assumptions that an Arduino class has to go through in order to succeed, and I find this crazy. First, students can access their serial ports. Second, they can work with a command line interface. Many people have no interest in doing this. Third, they can get a compiler working. Fourth, they can flash the microcontroller. Fifth, they can install Arduino, import libraries properly and the correct boards. Sixth, they have a good USB cable. You would be surprised how many people think they do, or maybe it's intermittent and it works sometimes and other times it doesn't. And then number 7, they actually enjoy doing all the things above. If you lose a student on any one of these, the class is over. And that makes an Arduino class a very difficult thing to teach, at least in my opinion. So we had a couple game changers that kind of brought me back to using microcontrollers to teach people. And one of them was web serial. Web serial means that I don't need to care about whether you use Arch Linux or Windows or Mac OS. You can open a Chrome-based browser and you can connect to your microcontroller, you can flash it, and you can take care of basically the first 3 assumptions we had with the Arduino one all in a web browser. That is incredible. The fact that we've eliminated the command line for beginners, at least in terms of working with these cheap microcontrollers, really changes the game when it comes to how a beginner can stumble into this and get started. It no longer matters that they're like a weird Linux person or whatever, and they're going to have some strange errors if they try to use a command line utility, although they'll probably be able to solve it, if they want to go deep on that. It doesn't disrupt our class anymore. Our average is just a couple of minutes to get somebody who is wandering in late to our class set up on the command line or set up flashing a microcontroller. That was unheard of a couple years ago. And the second is CircuitPython. So CircuitPython means that people no longer need to use a compiled language. So we've cut out the second set of assumptions, where now our students don't need to compile anything. So their computer can have the most messed up linkages, and like their dev environment can be completely cursed, and it does not matter to us. So CircuitPython is an interpreted Python compiler for hardware. It basically runs on the microcontroller, so you can type plain text Python, you can save it to the microcontroller, and it will run it. That's it. What's fantastic about that is you flash the microcontroller one time, and then you never have to compile the code. It's easy to control hardware. You can drag and drop text into the editor. You can use a mobile phone to connect to this. It will mount as a USB drive with text on it, and then you can open the Python code in any text editor, change it, save it, and it works. The experience is smooth, and there are some limitations that might frustrate the hardcore Arduino people that love having like very low-level control over everything, but I consider that to be fair trade for all of the advantages when it comes to getting up and running. So imagine you have a student who comes in and they're like, listen, I'm so sorry, like I don't have anything command line, I have a tablet. Can I participate in this class? We can say yes. That's crazy to me. You know, if someone comes in with an iPad, they can participate in one of our CircuitPython classes. That was like, you know, you can't do that, at least in the moment, with Arduino, at least as far as I could tell. So a lot of that is really incredible to me. And we've also had like people with Chromebooks. When we work with schools, they might have things where they're so locked down that the only thing we get is a Chrome browser. So this is, we've had some trouble with Chromebooks. We've gotten most of them working, but this is a way that we've been able to work with virtually any hardware we have and still pull off a hardware class. And if anybody's tried to do that before, you know it's very, very hard. So let's talk about web serial. Web serial has a huge impact on programming. You can flash a microcontroller with a compiled bin file. You can communicate with the microcontroller over serial if you're running commands. You can do project organization. So you can see here we have our USB nugget. Basically has a list on the website of all the different community projects that you can flash. And that means it's really easy for people to discover new projects that are compatible with the same piece of technology. It's really awesome. You can also flash and learn on the same website. So if you have a great tutorial page that includes a web serial link where you can click on it and flash the code that you're talking about, you can make a really engaging experience for students so that they're on the same web page when they're learning, as well as flashing and communicating with the microcontroller. Now we can make fewer assumptions. So with one of these CircuitPython classes, what are we assuming now? The student has Chrome. The student has a data-capable USB port, as well as USB cable, and then everybody has access to their serial ports. That one sounds trivial, but with Linux users, they often have to add Chrome to their dial-out group to access the serial port. I know that by heart now because that's the only error we generally have. So we've gone from having all these operating system like specific problems to all of a sudden having one. That is incredible. That really made me want to start teaching these classes more. So when we focus on microcontrollers for beginner, web serial really makes it possible for virtually anybody to get in on this and try for the first time. So with that being said, there are a number of different microcontrollers that I tend to use for these classes above all others, and I want to go through why I prefer them and which ones I would recommend if you're going to be teaching ethical hacking or just really anything with microcontrollers. These are my personal preferences. There are some other great ones out there, and I don't profess that this is a complete list of everything. So first up is one of my absolute favorites because I'm a Wi-Fi hacker by nature and I like anything that lets me do bad stuff with Wi-Fi. This little chip is incredible. It's the ESP8266. It has no native USB, so when you plug it in, it uses a little serial adapter, and sometimes I think it's been mostly resolved, but in the past you've had to install something to communicate with this, which is a little bit of a disadvantage. But aside from that, it's got Wi-Fi support, supports packet injection, but you're not going to be able to do things like capturing a handshake. So if you're a Wi-Fi hacker and you think you're maybe going to grab someone's password with this, it's not going to be possible because this little chip can only read packet metadata. Now, packet metadata is good enough for the NSA, so in many cases it's good enough for us when it comes to doing all sorts of sketchy, interesting things with Wi-Fi, but there are limitations to this chip as a result. It supports Arduino and MicroPython, but because CircuitPython only works with microcontrollers that support native USB, just to make it easier on beginners, there's a couple exceptions, but that's generally the rule, this does not support CircuitPython. Next up, we have the ESP32S2. I would say this is my second, maybe third favorite microcontroller. So this one does support native USB. It mounts itself as a flash drive. It supports CircuitPython, Arduino, and MicroPython. It does not have packet injection, even though it's newer and more powerful. And the reason for that is Espressif, the company that made the ESP8266, saw what our community did with that chip and was like, holy shit, never again. And they locked it down and made it so that the newer hardware is a little bit harder to do the sort of Wi-Fi hacking stuff that we so very love to do. As a result, I tend to not teach my Wi-Fi hacking classes on this one. I use the previous microcontroller for that. And instead, I focus on bad USB attacks and prototyping with this one, since it has such excellent CircuitPython support and because it has such excellent USB support. So in some of my classes, I taught kids how to make a auto clicker out of this one because it was the only thing they wanted to learn. So again, it does have Wi-Fi, so it does allow you to connect to wireless networks. You can sniff, you can do some very interesting things, and I think this one actually might be able to capture handshakes, although I have not done it myself. It is a single core, but that doesn't mean it's not powerful enough to do a lot of bad and interesting things. So I really like this microcontroller, and I run it in the majority of the devices that I work on today. This is, in my opinion, the future, the ESP32S3. This came out recently, and this is the S3 mini form factor, so it's in a little bit of a breakout board. The actual microcontroller itself is this little square here. But this one has native USB, mounts as a flash drive, again, CircuitPython, Arduino, MicroPython, but it also supports Bluetooth, and it's dual core. So if you've got applications where one core is going to be doing one thing, the other core needs to be listening for something else or working on something independent, having two cores is really, really nice. And so is Bluetooth, because you can make an application on your phone to connect to it. So we've also experimented with getting this configuration when combined with LoRa radios to support Meshtastic. There's some really cool stuff you can do with this microcontroller. Since it's a bit more powerful than the other two, it tends to be maybe $1 more expensive, but we're talking $5, so it's okay. Next up, we have the PiPico and the PiPico W. I actually don't use these as much as I use the RP2040 chip in various other form factors. But I really like the RP2040 chip. I think it has a lot of great applications. It does not support Wi-Fi unless you get the PiPico W variant, so keep that in mind. But for excellent USB support, I would say that this is a really, really great microcontroller with tons of documentation, a great community, and lots of projects that you can build with it. And that's really why I love Raspberry Pi as an organization. The community is so engaged, and they have so many great examples that guaranteed if you get one of these little things, you're going to find tons of community guides on how to do great stuff with it. So this year, we worked with a number of different partners. We worked with Null Space Labs to do classes. We worked with Missoula Public Makerspace to do a bunch of free Wi-Fi hacking and ethical hacking classes. Flathead Valley Community College, San Francisco State University, and Cyber Montana is a statewide organization that also gave us a bunch of grant funding to do our workshops this year. A lot of these people discovered us at events like this, and a lot of them discovered us by attending our classes. So it's one of the benefits of doing workshops constantly. But we also did a fair amount of outreach to make these happen, and I'm going to talk a little bit about our use cases and how we actually went through these. So the first and the one I'm most proud of is our 5-day CyberCat Academy camp. This was a 5-day cyber camp for students in Flathead Valley, and we did this at Flathead Valley Community College. They were great partners to us, and it was funded by a $15,000 grant from Cyber Montana. So Cyber Montana has the initiative to create these cyber camps all around the state, and they had nobody in our area. They saw our workshops in Missoula after I meticulously invited every single faculty member in Missoula to those workshops, and we're like, wow, this was really great. So they invited us back. We did some presentations to their students. They're like, okay, that was great too. Do you want $15,000 to do a cyber camp? So we said yes, but then the process was actually a lot more complicated than that. So we needed to win over support of our sponsor, the person who was actually going to be hosting the workshop, and that was actually talking to the people at the college and explaining to them why we weren't going to teach these kids how to do crime. So if you're looking for a playbook on how to do this, step 1, do multiple free classes at the library. Step 2, invite every board member of Cyber Montana to the classes. Step 3, repeat steps 1 and 2 until you get a grant. Worked great for me. So our schedule was crazy. We had a lot of stuff scheduled for every single day. We did 5 days, 5 hours of instruction each with a little break, and we were competing with Cookie Clicker. So we had the age of students where the second that we stopped instructing them, they popped open this Cookie Clicker mobile game and went crazy. And that was a big problem. We really struggled to keep their attention. So I'll talk about the ways that we managed to get it back, but I also wanted to talk about the objections raised by the school. They were like, you were going to be teaching these students things that could potentially get them in trouble. You were going to be potentially like touching subjects that we really don't want to teach. We really want to keep this maybe instructional and or like advisory and not hands-on. And I was like, I won't do it if that's going to be the case. So I had multiple meetings with faculty where we talked about everything from like Aaron Schwartz to like the ways that people need to like kind of give consent to do these sorts of things, explaining that to kids, how we were going to do it. And we had an entire section that was what makes ethical hacking ethical. That's actually the first thing that we did. So by the end of that, we had the kids calling out whenever someone would propose to do something that like violated consent or like otherwise had issues, and they were really strict about it. They did a really good job. So navigating the concerns of the teachers was challenging at first, but talking to them about the things that we already know about ethical hacking, the people who have paid the price for stepping over the line, and how serious that can be, really set their mind at ease that we understood our responsibility in teaching the ethics of hacking to these kids. So if you think you're going to teach an ethical hacking class without specifically calling out ethics, you're going to have a rough time, and you should plan for this sort of opposition from instructors, students, even people that you might not, parents, you might not understand objecting to these sorts of classes, and build in some of the ethical part of ethical hacking at the very beginning. This might not apply to all of you, but I just want you to know if you are teaching security classes, you are going to get some pushback, and this is something that we've learned to navigate by just being very upfront about it and making sure that our first section addresses this. So when teachers are like, how are they going to know? It's like, well, it's our first section. This is what we're going to cover. These are the examples we're going to cover, and this is how we're making sure that these kids don't go out and immediately, get in trouble with what we just taught them. All right, so as you can see, all of our days were scheduled in Sanity. We had everything from AI CTFs, which supplemented our hardware stuff, to soldering classes. This was pretty challenging with middle school age kids, and it just kept going and going and going. So again, the barriers that we had here were ethics. We definitely addressed a lot of these in prior meetings. The school wanted to take a significant amount of the grant funding. So they wanted to take about half the grant funding. And we're like, why? They're like, all right, how about a third? I'm like, no, but why though? They're like, fine, a quarter. I'm like, no, but why do you need this? Like, we'll take $500. All right, good deal. So often if they come back to you and say like, oh, we need this for overhead, for faculty, whatever, and you're just like, why? Like, it was not a very intense negotiation, but if I hadn't spoken up, we would have ended up with half the budget that we were assigned. So don't be afraid to ask why. Don't be afraid to negotiate a little with them. I found that this had great results for us. Getting the grant was complicated. It was a lot of back and forth and cost spreadsheets. We had some people to help with that, but just be prepared that they're going to want to know the breakdown for everything. But if things change at the last minute, nobody really cares. Or at least in this case, they didn't really care. So some of our subjects we had to move around, some of our times we had to move around. They really just wanted something to present, something to make sure that we had an idea and that we weren't just going to improvise this at the last minute. Helpers were also really hard to find, and several that the college referred were actually excellent. So if you're working or partnering with a venue that already teaches classes, asking them if they have any helpers who would want to participate in the class saved our asses. All right, so one of the things that we worked on that was incredibly successful, and I'm just going to go over some of our wins, I guess, was these 3D printed builds. So it costs less than $5 to make these 3D printed light boxes, and it was one of the favorite things that the kids did. When we partner with organizations that have access to 3D printers, maker spaces, libraries, like all these places that have 3D printers, we can get away with basically hitting them up a couple weeks before, asking them to print out some parts for the kids to put together, and do some incredible projects. So I went on Thingiverse and I looked at all these 3D printed light boxes until I found some designs I liked. I modified them slightly. I sent these designs ahead of time, and we were able to crank out these designs for maybe $450, and everybody was delighted by them. These are WLED capable, Wi-Fi capable, like LED boxes that you can connect to home automation. You can do all this great stuff with them. And again, $450 per kit. This was a soldering class and a programming class. Plus, we use these light boxes as targets later on. So for $5, like, I have to say this was an incredible value. And if you're partnering with anybody that has access to 3D printing, I would recommend these sorts of projects with, you might recognize the D1 Mini right here. That's the ESP8266. So at a cost of about $1.80 for the microcontroller, and then a little bit extra for the wires and parts, this is a great project, and a lot of people got a lot out of it. You can see the 3D printed files are up and available if anybody wants to try this out yourselves, but for programming, soldering, this is a great class. Again, these parts, $1.88 and 46 cents. So I guess, I don't know where I'm getting $5 from. Maybe the cost of 3D printing plastic was really expensive back then. But this is an incredibly cheap project to get people engaged, and one of the first that we had the kids learn. So again, winning strategy is if you have access to printers and you can provide the filament, you can use those low-cost parts to make IoT devices of various types. There are some very cute ones out there, and I've found that this is one of my most popular strategies for getting makerspaces or other spaces engaged with us at a very low cost. If they give you a budget of $100 and you've got, like a bunch of students, this is a project you can still pull off. And I've had to do that many a time. So we made some future modifications. So if you want to come by today, we're actually doing this at the hardware hacking area. So we're going to be making IoT like hex leafs, as well as possibly pushines. So it's a modification of this project where we just print out these hexagon tiles and diffusers, and instead of making the box, we can actually make these tiles. So we've kind of iterated on this. It's still a very popular project, and it's something that a lot of people really like. So next up, I've got an example right here. We have beginner-focused microcontroller development boards. These are open source boards that I've been working with a variety of friends on for the last several years on making these more simple to teach with. So originally, these microcontrollers I showed you are great, they're powerful, they have cool features, they're low cost. However, they are not maybe the most accessible for making your own prototypes. Maybe they can run some of this stuff, but you still need command line, and that might not be appealing for beginners. So I worked with some friends, the most direct contributor being Alex Lin, who some of you might know, on creating this open source development board that has a built-in screen, an RGB LED, 4 D-pad style buttons, Wi-Fi microcontroller integrated, and then plug and play GPIO pins to make it so we could teach these classes in a way that was way more beginner friendly than just giving them this mysterious looking board. This allowed us to do a lot of things. And the inspiration here was my cat, Hand Banana, who also goes by the name of the Nugget. So we took a microcontroller, added the cat theme, and then boom. You might notice that on every one of the Nuggets, there's this illustration of my cat. He's got a short, stubby tail, so you'll probably recognize him. So if you want to know what inspired this project, that is what did it. So what's under the hood? We talked about the ESP32S2. This is the variant that I use most often for my classes. And again, this has native USB, Wi-Fi, all the things that I want for teaching a class when I need power and also connectivity. We can do bad USB attacks. We can support any of the programming languages I mentioned before, CircuitPython, MicroPython, and Arduino. We can control hardware and sensors. We can run a lot of community projects on this. Whether or not the screen always works is, it depends on the project. And then we can also do Wi-Fi networking stuff. So that's fox hunting, all sorts of cool, interesting Wi-Fi hacking things that students love. Wi-Fi hacking tends to be one of my best subjects, so making sure that this was oriented towards Wi-Fi hacking was a particular point of interest. So my friends and I also worked on the USB Nugget OS, and this has gone through many updates. The current maintainer is my friend Brandon, but the original creator was a combination of myself and Alex Lin. This is a program that lets you do all these bad USB attacks, and Hack5 actually asked us to stop using Ducky script. So we now do cat scratch, which is the same. And we have built-in flash storage drive, quick payload deployment, a Wi-Fi control, which means Wi-Fi control, and a number of built-in demos. So if somebody comes in and they say, hey, I want to take this class, it's a bad USB class, but I only brought my iPad, or I only brought my phone, that's totally fine. Not only can they plug this in and connect to it over USB and edit their payloads, they can also connect over a web interface, with which my friend Brandon created, and actually run these payloads from there. So really cool. And we've been working on a number of extensions that even like manage to expand this capability. We have some LoRa radios we just released that can make this be triggered from multiple miles away. So we've been upgrading this and kind of making the capabilities more and more exciting as we develop it. So what is the design and functionality here? Well, we decided to break up microcontrollers to be more useful for teaching. We wanted it to be cute, cat-themed, and beginner-friendly. We don't want it to be utilitarian or weaponized. So much of cybersecurity is like making computers that basically look like guns. And that's fine, like that certainly has its application, but because we talk to a lot of beginners and not all of them are the same. We have a lot of people who are coming from different areas, we have a lot of people who are younger. Not everybody aspires to a computer gun. Some people do, and again, that's fine, but making ours cuter, more accessible, friendlier was a big design focus from the start. And we also wanted to include all the basic components needed for prototyping. So if you're trying to build something that is reactive, that engages others, we wanted a platform that actually supports that. So my inspiration for this was the Deauthor wristwatch, actually. If you've ever seen it, the Wi-Fi Deauthor has a number of different iterations, and I think the Deauthor wristwatch is as close to a hit as has come out from that. It's portable, you can do most of the functions that it supports from a screen, and I really admired this design, and I thought it was super cool. So I ended up talking to Spaceyun, the creator of the Deauthor software, and I was like, I really want to make something that is friendlier than this, but basically takes some of the best parts and iterates and goes a step further. Because this is fragile, it's quite bulky, it's actually a terrible watch. It's like one of the worst watches. So like, while I love a lot of features of this, I wanted to make something a little different, and that's where the inspiration of the Nugget kind of came from. We also tried to design for the educational experience. So one of the things that I really wanted to get working was the nugget.dev website, which allows you to find available projects for the hardware, flash those projects, and communicate with the board all in one place. That means I can have everybody at the class go to a single website, they can connect to it, find all the software we're covering in the class, and communicate with the microcontroller, never having left the website. Pretty easy. And actually, my friend Angelina is the one that made this website, so if you saw her talk yesterday, she's also a good friend and on our team. So the result is that we can get students caught up in 3 minutes. That means if you walk into any one of our classes, I'm hoping, and you are late and you have no idea what's going on, one of our helpers can sit you down and get you caught up with the rest of our team or with the rest of the class in 3 minutes or less. That is an amazing number for me, and we've worked really hard to get there. If you've ever had a student walk into your class before and tried to see how much it disrupts it, you'll know that 3 minutes is incredible for getting somebody caught up to the rest of the class, regardless of what part of the class we're in. So we ran our Bad USB scripting class at our CyberCat Academy, and this was a huge hit. The kids, unprompted, went up to the front and started showing us their scripts, such as the Computer Cooler 3000, which shut down the computer really hard and fast, and the Computer Heater 5000, which opened infinite Chrome windows in a loop. We actually had kids, again unprompted, take their USB nuggets home, write their own scripts, and come back the next day and ask to present to the class. So if you're looking for something that allows kids to be creative and express themselves, share their favorite memes, some of which were super weird and very loud, this was something where we actually found that students took these devices, plugged them into their computer, saw the default Rickroll example that we included, and modified it, before we even covered the subject. So for something that's relatively self-documenting in that way and lets kids start working on it before we even tell them to, this was a big win. And the bad USB classes teach people who don't know how to program what a program structure looks like and how to organize a list of things that have to happen to achieve a result. So for teaching pseudocode and for teaching students who have never done this sort of programming before how to pop open a meme on a Windows computer, these kids were incredibly proud and they brought their best productivity to this. We also taught them how to run a lot of these memes from the serial terminal, so we got them comfortable with serial terminal via things like parrot.live. This was one of my favorite payloads. It just opened a bunch of dancing parrot windows. But this got kids to want to know more about what they could do with the command line window because they wanted to do more bad stuff. And that's fine. We wanted to get them interested in the first place. They had zero interest before we did the bad USB attack class, and I just wanted to shout this out as one where it was not only self-documenting, but also highly engaging to a bunch of middle schoolers. Less great. All right, our CircuitPython class had some issues. Our primary issue is that flashing CircuitPython erased the bad USB scripts the students had worked all night on. We did not tell them that. We should have told them that. 2 of our students cried because they had worked all night on their bad USB scripts and they were now gone. So if you're working with microcontrollers, you need to be aware that when you flash them, you erase the stuff that happened before. That's not really the case with the Raspberry Pi. You know, you can work on one project, switch to another, but when we're switching subjects on this, we can make kids cry by accident. That felt very bad. So students who were using Raspberry Pis also unzipped the files that we were trying to drag and drop onto the microcontrollers differently. There were 2 different options, and everybody either clicked one or the other, never the same. So as a result, we had a lot of people who were dragging and dropping stuff that didn't make any sense to their microcontroller. It didn't work. The only way we got students to care, at this age anyway, about making Python was to create an auto clicker so that they could win at this cursed mobile game called Cookie Clicker. So in the future, I'm going to make a pre-built image with CircuitPython and built-in examples like an auto clicker so that they will have a more smooth experience. Getting them to install this themselves was a bad idea, and I do not recommend it. However, I did find that if you can get them to play their favorite mobile game, then it tends to go a little bit better. By the way, we used Raspberry Pi 3B pluses for all of our students so that they would get so hot that they would thermal lock and start to throttle when they played mobile games, and that was actually a pretty successful strategy. So we actually passed around a thermal camera and had them measure the temperature of their Raspberry Pis to see who had gotten it hotter, and that was enough of a release that they didn't really care that their computers started locking up. So obviously, I said that this has a screen, so we can display animations. We can make this so that it's very appealing to students. And we had a couple students draw art on a whiteboard. Actually, the girls in our class started drawing on the whiteboard, and I showed them during a lunch break how we could actually take a picture of that, put it into GIMP, and then put it up on their microcontroller. And all the other students were like, I need to do this immediately. So if you're looking for a way of engaging people, taking art that they make themselves and showing them how to create an animation or showing them how to put it up on the microcontroller, surprised me. I didn't know that they would be that into it. We wasted, well, we didn't waste. We turned an entire lunch break into just teaching people how to do this. So that was something that ended up being a win. We also made a ton of AI-generated stickers that became a currency. These people were selling each other out for these stickers. Like, they were very, very dedicated. We used Sticker App, and we got 25 unique images per sheet, 100 total, and we had $200 for like prizes from our grant. So honestly, like $200 for prizes for like 20 students is not very much. We felt like we couldn't really do much with that. And with these cute stickers, honestly, the students were fighting each other for them. Like, it was really intense, the competition. So they did exactly what we were hoping for. You even had students come early and like help us cut the stickers and to like secretly get to pick which like the very best ones that they could get. So 3D printed stickers ended up being a phenomenal choice. All right, total injuries, 1 mild soldering burn. We did our best trying to get everybody familiar. We made this funny, like, will they get burned soldering class with memes. And ironically, one of the kids raising their hands the highest is the one that actually burned themselves. You know, but they did not care. It was just their parent came in the next day and was like, hi, I would like to know how my child got burned learning cybersecurity. And I was like, oh, we're making microcontrollers. She's like, listen, he doesn't care. He loves it. He's excited to be here. He won't shut up about it. I'm just curious. So you might face some student questions if you do that. So feedback. We got a lot of really interesting feedback from the kids. I want to go over some of it. This one just says, what did you like best about your class? Hack. And then also 3D printing, coding. That's pretty good. What did you like best about the class? The nugs. And then hacking, all right. What did you like best about the class? The fact that there's cats. And then what other class did you want to take? Cybersecurity. And then one of the kids actually made these cards for our instructors, which I thought was incredibly sweet. Thank you for teaching CyberCat Academy. Seriously, you guys are A++++ to your teachers. You guys are the best. Price. I won't read the other ones, but they are all incredibly cute. And this was very, very rewarding to do a class and get this kind of feedback. So let's talk about the Missoula Makerspace. This is something where I went and taught a couple of free classes, like 1 or 2, and then I was just like, I can't keep doing this. I'm going broke. You know, like I have to pay for everything. They were great about hooking us up with, in their case, it's called Friends of the Missoula Library, but it's a board of people who fund programs at the library. We wrote a brief description. We had the person in the Makerspace carry the ball for us, and we were able to get this proposal funded in about a week. So this gave us a budget to keep the classes free for all of our students. And we did have some hiccups. Because these classes are free for students, we have an up to 50% no-show rate. So if people register for this class, we might end up still having a half-empty class and have basically no ability to seat other people because they thought the class was full. So the library buys the materials and provides the classes for free. We usually end up losing a little bit of money on this, like with travel and expenses, but frankly, getting to meet people in the community and all the different opportunities it's opened up for us ends up being worth it. So if you're looking for a model that has the students coming for free, then a lot of these library makerspaces have a lot of funding for programs and not enough people to teach them. So I found that there's a lot of money kind of floating around in the library, makerspace, education world. And if you're somebody who wants to get into doing these sorts of programs, then it only takes a little proposal and maybe some photos of happy people in one of your workshops to get this pushed through. So we did our community soldering projects back to back in some cases, and the IoT Lightbox was by far the most successful. So if you're looking for any projects to pull from my presentation that can make you money on a shoestring budget, or at least not lose you money, the IoT Lightboxes are still some of the standout winners in a variety of different workshop environments that I've done. So Nullspace Labs is another one of our partners. We've had some fantastic people get their start teaching classes at Nullspace Labs. And the idea is that we can get people who are maybe either relatively unknown, new, coming up, and we can get them to partner with one of these hackerspaces in order to raise a little funding for the hackerspace and also get new people flowing through. So often one of the biggest problems with hackerspaces is how do you get more people into the hackerspace, how do you make it beginner friendly, and how do we raise money when we're in a crisis? Well, these classes don't raise a ton of money, so often it's like a couple $100s for the space, but the idea is a certain percentage of the tickets is donated to the space. A lot more people get to interact with the space, get to know it, hopefully sign up as members, and try to utilize these spaces that often are either not used all the time or maybe are in need of more funding or members, and get them to partner with us in bringing our instructors to their people. So these are great because they tend to have excellent social media and great reputations. So if you're looking for an organization to partner with that will allow you to reach a lot of students, hackerspaces are almost always in need of these sorts of classes. So look at your local hackerspace. In Los Angeles, it's going to be Crashspace or Nullspace Labs. I've been to a lot of other hackerspaces that I like very much. Hack Manhattan was fantastic about helping us out with classes. Noisebridge, I'm planning on doing some classes at, as well as Quirius Labs in San Francisco. So there's lots of great hackerspaces out there who would be up for supporting you if you're looking to teach a class and want to keep the class free for students. If they've got funding. Anyway, so my conclusion on this is that microcontrollers are now a much more viable way of teaching beginners. If you've been holding off on this, the prices are now to the point that even if the classes aren't sponsored, you can still get away with some pretty incredible stuff for a budget of about $5 per student. This is teaching programming, soldering, a lot of the things that there's money out there for. So if you're upfront about what you're trying to teach, there's a lot of organizations that are willing to either provide grant funding or a venue for you that costs essentially nothing. So I love reaching as many people as I can, and navigating this to try to get in front of as many people as possible has definitely been challenging. But hopefully you've learned a little bit about how you can take even a shoestring budget and use microcontrollers appropriately to teach everything from Wi-Fi hacking to IoT, automation, CircuitPython programming. There's really a lot out there for anybody that wants to learn. So if you've got a grant for us, feel free to reach out. We do this stuff all the time, and we do workshops, hardware, hacking, programs, cyber camps. We're also going to be at Tour Camp coming up, so if you're going to be there, we'll see you there. And we have an entire booth in the back of the hardware hacking area where we're going to be running workshops also for the rest of the day, and we'd love to see you. And if you want to try it yourself, we also have all of the stuff that we do with our workshops, the nuggets, everything else on our website. If you're an educator and you're looking to do a class, a lot of these are open source, and we'll just send you the files if you want to make them yourself, or we can also cut you a fantastic deal if you're going to be teaching a workshop and you want to buy a whole bunch of them. And that's pretty much it. If you want to keep in touch, you can find me on my personal website, hack.gay, one of my favorite domains I've snagged. You can find our store at redia.io. And if you want to check out some of the infrastructure we've created around the microcontrollers we teach with and sell, you can check out nugget.dev. We make all of our nuggets in Kalispell, Montana, and you can see one of our inspectors here taking a look at one of the fresh batches. But a lot of our team who makes this and teaches are going to be in the back of the hardware hacking area if you want to come and say hi to us today. Thank you very much, everyone.